In this video, we will study the necessity of starter for DC motors and 3-point starter which is used for DC shunt motors. Let us now see first why starter is required for DC motor. So in case of DC motor, we know that when the voltage is applied to the motor, its armature starts rotating. And when it rotates, it cuts the flux. And therefore, an EMF is induced in the armature. And this EMF is opposite to the supply voltage V. That's why it is called as back EMF. So as EB is opposite to V, net voltage across armature will be V minus EB. Therefore, the current drawn by the motor IA is equal to V minus EB upon RA. So, the current drawn by armature IA, it is given by V minus EB upon RA. Now, before starting means when the motor is at rest, the speed of motor N is equal to 0. And as the armature is not rotating, it will not cut any flux. And therefore, EMF induced in armature EB is equal to 0. We also know the expression for EB. EB is 5Pn upon 60 into Z upon A. Now, at start n is equal to 0, and if n is equal to 0, EB is also equal to 0. And if EB is equal to 0, the expression for armature current IA will be equal to V minus 0 upon RA, which is nothing but V upon RA. Now you know that the resistance of armature RA is very small, and therefore the current drawn by the armature at start will be very large. And therefore, if the motor is connected directly across the rated voltage supply, it will draw large current from supply, because at start n is equal to 0. As n is 0, EB is equal to 0, and as EB is 0, IA is equal to V upon RA, and RA is small, and therefore IA will be very large. So let us see one example. Suppose the resistance of armature Ra is equal to 1 ohm, supply voltage V is equal to 200 volt, and the output power or power rating of motor P is equal to 5 kilowatt, which is nothing but 5000 watt. So the rated current of motor will be equal to 5000 divided by 200. So it is equal to 25 ampere. Means when the motor is fully loaded, it will draw a current of 25 ampere, or I full load is equal to 25 ampere. Now, if the motor is connected directly across the supply, then the current drawn by the motor at start, that is starting current, will be V upon RA, because EB is equal to 0. V is 200 and RA is 1, and therefore starting current is equal to 200 ampere, whereas full load current is 25 ampere. It means that in this particular case, the starting current is 8 times greater than the rated current of motor. So it means that if the motor is directly connected across the rated voltage supply, then motor will draw large amount of current at the time of starting. We have seen that if a DC motor is connected directly across the rated voltage supply. It draws large current at the time of starting. So this excessive starting current, it will blow out the fuses and the motor will be disconnected from supply. But before that, the parts like commutator, brushes, etc. may damage because of this excessive starting current. At the same time, this excessive starting current will cause large voltage drop in the line, and therefore the voltage of line will also reduce. And that's why the performance of other loads connected to this same line, their performance may also get affected because the supply voltage will reduce because of the large current drawn by the motor, and therefore the current at the time of starting must be limited to a safe value. So this can be done either by applying low voltage at the time of starting or by connecting a variable resistance in the armature circuit at the time of starting. So this starting resistance Rs is a variable resistance and it is connected in series with armature. And because of this Rs, now Rs and Ra are in series, and therefore the total resistance of this path will be Ra plus Rs, and therefore now the starting current will be V upon Ra plus Rs, because Ra and Rs are connected in series. So because of this Rs, the starting current will be limited to a safe value. But this resistance we need only during starting. And the starting time is usually of the order of 5 to 10 seconds, depending upon the size of motor. So as the motor picks up the speed, means when the armature starts rotating, it will cut the flux, then back EMF will be induced, and this back EMF is opposite to supply voltage V, and therefore current drawn by the motor will automatically reduce, and after that there is no need of this starting resistance. So at the time of starting, this starting resistance is kept at maximum so that starting current will be minimum. And as the speed of motor N goes on increasing, the starting resistance is reduced because with increase in speed, EB increases and current decreases. So therefore, this starting resistance Rs is gradually cut out of the armature circuit, and finally this Rs is reduced to 0. Then the motor will operate under normal operating conditions with 0 resistance connected in series with armature. We have seen that whenever DC motor is started, it should be started with the help of starter to limit the current at the time of starting. However, if the motor size is small, then the motor can be started directly without using starter. This is mainly because of the three reasons. The first reason is if the size of motor is small, then armature resistance Ra is relatively large. So if Ra is high, then current drawn by armature Ia will be low, and therefore the motor can be started without starter. The second reason is in case of small motors, their moment of inertia is low and hence their speed increases quickly. As speed increases, back EMF EB increases and current IA decreases. And therefore, small motors we can start without using starter. And the third reason is, in case of small motors, the magnitude of starting current is small. And therefore, due to this small starting current, large voltage drop will not be produced in the line, and therefore supply voltage will remain constant, and that's why the motor can be started without starter. Let us now study the construction and working of 3-point starter, which is used for starting of DC shunt motors. This starter, it is called as 3-point starter because it has three terminals, L, F and E. Terminal L is connected to positive of DC supply, means L is connected to line. Then terminal F, it is connected to the shunt field winding. So F is connected to F1, F2, that is shunt field winding. Now in series with shunt field winding, there is a variable resistance R. The function of this resistance is to control the speed of motor with the help of flux control. Then third terminal A, it is connected to armature. Then remaining terminals of armature and field must be connected together because in this case armature and field are connected in parallel, and this common terminal is connected to negative of the supply, and therefore A2 and F2 are connected together and it is connected to negative of the supply. Now here the schematic diagram of 3-point starter is drawn. So you can see that there are three terminals, L, which is connected to positive of supply, second is A, which is connected to armature, and third is F, which is connected to the field winding. Now let us see what are the various parts of this 3-point starter. So this H, that is handle or starting arm of the starter, and when the motor is at rest, this handle will be in this off position and it will be held in this position due to the spring tension provided by this spiral spring S. So because of this spring S, the handle will remain in off position when the motor is at rest. Then there is a graded resistance. Now in this case, we have shown 5 different steps, and this graded resistance, it is connected in series with armature. Then there is one electromagnet which is called as no volt release or low volt release, and this electromagnet carries a winding or coil, and this coil, it is connected in series with the field winding, and therefore current flowing through the no volt release coil is equal to the shunt field current ISH. And there is one more electromagnet which is called as overload release, and the current flowing through the overload release is the current drawn by the motor, that is load current IL. So this is shown in this schematic diagram also. So here the current flowing through the overload release is IL. Then in series with armature, there is a starting resistance, and this resistance is a variable resistance. Then no volt release coil, it is connected in series with the field winding, and therefore current through no volt release coil is the field current ISH. So you can see that there are two parallel paths. One path is of armature current IA and second path is of field current ISH. Now when the motor is to be started, we have to close the main switch M. So this switch must be closed. So when the switch is closed, then supply reaches up to the handle or up to this starting arm. But the motor will not start because the handle is in off position. Now to start the motor, we have to move the handle and it should be in contact with this stud 1. So when the handle is moved up to the first stud, then this entire starting resistance, it will come in series with armature. At the same time, field winding also gets supply through this path. In series with field winding, there is a variable resistance R and there is no volt release coil. So because of this starting resistance, now resistance of this path will be equal to Ra plus Rs, where Rs is the resistance of all these 5 steps. And because of this Rs, the starting current will be limited to a safe value. So here this starting resistance, it entire starting resistance, it comes in series with armature, and therefore resistance of this path, it becomes Ra plus Rs, and because of Rs, starting current is limited to a safe value. We have seen that because of this starting resistance Rs, which is connected in series with armature, the starting current will be limited to a safe value. Now once the motor is started, speed of motor N goes on increasing. And as speed increases, back EMF will also increase. And with increase in back EMF, current drawn by motor will automatically reduce. And therefore, when the motor gains sufficient speed, we have to reduce the starting resistance. So starting resistance can be reduced gradually by moving this starting arm over these various studs, that is 2, 3 and so on, up to the final position, that is stud number 6. So as the arm is moved, the resistance in series with armature goes on reducing. And finally, when the handle is in the run position, in that case, the entire armature resistance is cut out of the armature circuit, and the resistance in series with armature is reduced to 0. Now the handle is held in this position because of this no volt release magnet. So this no volt release magnet, it is also called as low volt release or no volt release, and current through this no volt release coil is the field current ISH. So because of this field current, magnetic field is produced and the soft iron piece which is attached to the handle will be attracted by this no volt release magnet. And if the force of attraction is greater than the force exerted by the spiral spring, then the handle will remain in this final position. And in this final position, the resistance in series with armature is equal to 0. We have seen that this handle or starting arm, it is held in this final running position by this no volt release magnet, and therefore the no volt release coil is also called as hold on coil. The function of hold on coil is to hold the starting arm in the final running condition during normal operating conditions. Now if supply fails or if the supply is disconnected, then every time the handle should return back to the off position. Otherwise, if it remains in this position, then if the supply restores, the motor will start directly without starting resistance, and the motor may get damaged. And therefore, whenever the supply voltage becomes low, or whenever the supply is disconnected, or whenever the supply fails, then the handle should return back. Now, when the supply fails, current flowing through this no volt release coil is reduced to 0, and therefore this magnet is demagnetized. So its magnetic field reduces to 0, and therefore it cannot attract the soft iron piece attached to the handle, and because of the spring tension, handle will come back to the off position and motor will be disconnected from supply. So whenever supply fails, this handle automatically returns to the original or off position, and the motor is completely disconnected from supply. Another function of no volt release magnet is to provide protection against failure of field. Now if field circuit becomes open, current through field winding will become 0. If there is no current in field winding, phi will reduce to 0 and the motor will run at dangerously high speed because n is proportional to 1 upon phi. So whenever there is failure of field, there is a danger of motor operation at very high speed. So this can be avoided by this no volt release magnet. So the current through this no volt release coil is the field current ISH. Now if field current becomes very low or if the field current becomes 0, then this magnet is get demagnetized. Its flux will reduce to 0, and because of that it cannot attract the soft iron piece which is attached to the handle, and therefore because of spring tension the handle goes back to the off position and the motor will be completely disconnected from supply, and therefore because of this no volt release magnet we can prevent the operation of motor at dangerously high speed because of failure of field. The protection against overload is also provided by 3-point starter. For that purpose, this overload release magnet is used. The overload release magnet carries the load current IL. When the motor is overloaded, motor draws more current from supply. So this current is flowing through this overload release magnet. So current flowing through overload release coil is the load current IL. As the motor is overloaded, IL will increase. So the magnetic field here will become strong and the magnetic field will be sufficient to attract this plunger P. So this plunger P will be attracted. So because of this strong magnetic field of overload release magnet, this plunger P will be attracted and it will short these 2 points which are connected across the no volt release coil. So whenever the plunger is attracted, the no volt release coil will get short circuited. So if this coil is short circuited, all the current will flow through short circuit and current through this coil will reduce to zero. So if there is zero current in the no volt release coil, it cannot attract the soft iron piece, and therefore because of spring tension the handle will return back to the off position. So whenever the motor is overloaded, this plunger will be attracted and it will short circuit the no volt release coil, and therefore no volt release magnet gets demagnetized and the handle will return back to the off position and the motor will be disconnected from supply, and therefore protection against overload can be provided. However, in practice, normally the overload protection is provided by overload relay. Normally, thermal overload relay is used for motors. The motor can be stopped by opening the main switch M. When switch M is opened, current through hold-on coil will reduce to zero. And because of zero current in hold-on coil, the handle will return back to the off position. Then the motor will be completely disconnected from supply. So because of this, it prevents accidental starting of motor without starting resistance. Here resistance R is provided for speed control. Speed of the motor can be increased by reducing the field current, that is by increasing the magnitude of resistance R. So when the field current is reduced, the current flowing through the no volt release coil will also reduce. And therefore, the magnetic field produced by this no volt release magnet will become weak. If magnetic field becomes weak, then the force of attraction will not be sufficient to hold the handle in this running position. And in that case, the handle will return back to the off position and the motor will get disconnected from supply. So this is the main drawback of 3-point starter. Means whenever the field current becomes low than certain value, the handle may return back to the off position and the motor may get disconnected. So this drawback or this difficulty can be overcome by using a 4-point starter. So this 4-point starter we will study in our next video. Thank you.